Everyone. Welcome to my presentation on software development tips for game jamming. Um, my name is Adrian. I am the co-founder of Complex Games and uh, been doing this for a very, very long time. So we'll just get right into it. Uh, One of the things that makes software development challenging is that we don't often think of it this way, but we are storytellers and we are trying to tell three different stories with the same document. The software development, you're trying to tell three stories with one document. The first one being uh, the user story. So this is what is it that you're actually communicating to the player with your code. So the person who's playing your game, that is what they are experiencing. Second part are the what I call the metal stories. This is obviously the instructions that you have to give to the computing platform in order for it to actually tell those user stories in the first place. Um, And this is where we care about, efficiency and memory allocation and all that kind of stuff. And then the last bit is the developer stories, which is what you're telling your team. And if you're not working on a team, it's what you're telling yourself 8 months from now when you go back and look at your source code and try and figure out what you were doing. And it's important to try and keep all of these stories in balance. Obviously, if the user stories are not if they're not well represented, then you've got a game that is not fun to play or is buggy or frustrating. If it is not communicating with the hardware well, then it's either not going to be performant or it's going to have runtime errors. It'll crash. And if your developer stories are out of alignment, then you're going to have a really hard time maintaining and developing and adding to your software as the project goes along. So on the developer story front, one of the ways to try and help manage that is something called Solid. And in great programmer fashion, it's a 5-letter acronym made up of 3-letter acronyms, which makes it probably the best and worst mnemonic for all of this. And so SOLID stands for the single responsibility principle. This is the idea that a thing in your code should only do one thing. Then there's the open and closed principle, which is that things should not be open. They should be closed to modification, but they should be open to extension. So if you want to improve them, you can, but you're not really supposed to change them. The Liskov substitution principle, this is essentially the idea that, if you, for example, if you have a car and you want to buy an aftermarket part, it needs to be functionally identical to the thing that you are replacing it with. If the spark plugs don't fire at the same rate, or if they don't fire at the same temperature, or they melt at a different temperature, like there's going to be problems. And so if you are creating a child class, then it should be completely indistinguishable from the parent class if you were to swap one out. The I is for interface minimalism, the idea that you want to keep interfaces small, have small sets of public methods that are for doing the task and keeping them together, as opposed to having, these kitchen sinky Swiss Army knife code objects. And then the last one is the dependency inversion principle. And this is a don't call us, we'll call you kind of system. If you think about how a well-structured organization might run, right? The people who are at the high level, right? The C-level people and the managers, they really shouldn't be telling you exactly what to do. They should be telling you what they want done and trusting you to achieve it. And so really the work gets done in the lowest levels of code, and the higher level code is there just to kind of keep things organized and manage the direction of everything. The idea here is basically that you're building kind of like software Lego. If you are able to construct something that is modular and sticks together well and can be pulled apart easily, because each individual piece by itself is not super complicated, but the larger system can be built up from those pieces. then you've got something that's much easier to change on the fly, because if you decide that you no longer need something, you can just throw it away. It was one small, tiny little chunk. If you need to reorganize things and rearrange things, you can quickly pull things together, and the parts that are still useful can be stuck back together in a new configuration. All this really basically means that the goal of solid design when you're coding is to only, as much as possible, write new code. Um, and this is because there's really two kinds of bugs. There's the bugs that happen when you're developing an idea, when you're trying to actually make it work the first time. And then once you get all those bugs fixed and you're pretty happy that the thing is finished, the other types of bugs that crop up is when you change a system. Anytime you change something, there can be knockoff effects. And if you are building your code in a way where things are more Lego-y, then you're going to see fewer of these sort of domino chains. Um, so something that developers often complain about is the idea that, the act of trying to fix bugs sometimes creates more bugs. Um, if that is happening a lot to you, that is probably because you're not building your software in a way that is designed uh, to be pulled apart, stuck together, and changed quickly without breaking. It's fragile, and all of those solid principles are things that will help you in that. And in the case of a game jam, like, you want to be able to move quickly. So having a lot of simpler scripts that do almost seemingly trivial things is better than trying to build, one or two or five major scripts that handle most of your game code. Um, in terms of that single object dependency, one of the things that helps is to think of classes as verbs. Think of your code as abilities, not actual things, not nouns. So if you have things like your health manager and your damage taker or your inventory holder, um, those are actions and concepts. And instead of organizing things like monsters and players and weapons, because then you start to build a hierarchy of relationships that are really more about, like, what collections of abilities do they have rather than what they are. And that way, then you can say, well, okay, a monster is, an AI controlled entity that has health, um, and drops loot, and a player is an input controlled entity that also has health but has an inventory system. And then that way the health system can be shared between the monster and the player without actually having the monster and player have to be related to each other, because they're not otherwise all that similar. Um, One way to really get that concept of small pieces and that modularity is to, I really stress, don't declare public variables. And if you're working in an environment like Unity, there are ways to get around that by using the serialized field attribute on a private variable, so that it will show up in the inspector. But depending on the platform, this might be a rule that you have to bend. But basically what it comes down to is that if data is public, it can be accessed and changed without the class that owns it ever knowing. Um, Whereas if the data is private and access to it is controlled through functions or accessors, um, then you always know that there is some code that is involved in making any change to the state of the object. And this is like the one easy to do thing that sets you up for success. Um, So going back to that dependency inversion, is that sort of that ask, don't tell style um, of flow control. It's about providing resources, not the implementation. Um, and it's basically this kind of, if you follow or have read the Picard management tips, it's that, right? On the enterprise, Picard is getting the information from people. He's not telling his staff how to do their job. He's not going down to engineering and overriding Geordi. He is like, we need the warp engines capable of getting to 9.9, in the next 3 minutes, or we're gonna die. Can you do that? And Geordi's like, sure, I'm on it, and makes it happen. Um, from a practical example from a code perspective, for example, say you have like a rendering engine. One way of building a rendering engine might be that your rendering engine uh, asks the renderable objects for information like the textures and the geometry and whatnot, and then takes responsibility for rendering all of that on the screen. But that's the strategy where the high-level object is doing all the work and the low-level objects is just feeding it information. Flipping that around, you can say if all of your renderable objects have a draw method that takes the rendering engine, and the rendering engine provides basic commands like draw a texture, draw a mesh, and so on, then each new object that you create, if you come up with something that you need to do that's new, you're not adding to the rendering engine to do it. You are adding new types of renderable objects in order. So it really, dependency inversion is about coming down to the idea of, if I wanted to add a new thing, would I be able to do it by just adding new code, or would I have to go back and change something that had been previously done to support the new functionality? Because at that point, that's when you run the risk of things starting to break and falling apart. This is more of a C# type thing, but knowing your structures is a really helpful way in terms of improving, not wasting your time. Arrays are kind of a pain to work with. Lists are easier because you can just add and remove things. But if you're not really storing lists of objects and you're trying to store just collections of objects that you want to be able to quickly add and delete or find the relationship between, then things like dictionaries or hash sets are going to be simpler. If you're familiar with LINQ or generic style programming, that often gives you access to algorithms that work on simple concepts and can save you a lot of time. You just sort of chain things together, and it again becomes that sort of Lego-like thing. You spend less time writing for loops and more time saying like, hey, can you find me the thing that matches this set of parameters I'm looking for? Really, all this comes down to is that perfect is the enemy of the good, especially in a game jam, but in any kind of professional environment, time is always your scarcest resource. In the scope of a game jam, your developer effort is absolutely going to trump your performance. There is nothing that you are going to do over the next 24 hours that is going to push a modern computer to its limits. So you don't need to worry about efficient, at least not from a computer standpoint. You need to worry about efficient from your time standpoint. If you can use a library, if you can use an asset store library or something along those lines, use it. And so you really want to focus on your core loop and get the simplest version of your game working as quickly as possible, and then just layer it out like an onion, just adding more, so that you're never more than 5 to 10 minutes from playable. For some definition of playable, your simplest version of your game might be just an object that is moving around on the screen under keyboard control and is nothing like what the final goal is going to be. But you don't need to build, the AI before you have something that's testable and interactable, especially because if you're trying to get a sense of whether or not you like where something is going as an exploratory path, it's much easier to be able to iterate on things quickly and test them out and get feedback from the rest of your team than it is to just go, this is what's going to work, and spend all your time building it. And then once it's done, you're like, oh, no, this is actually kind of boring. Lastly, the most important piece of information is ignore anything that I've said in the last 10 minutes if it's going to slow you down. If you're not used to a solid workflow, these are things to think about, but if they start to clash with your workflow and your way of doing development, maybe a game jam is not the time that you want to do it. Maybe it's the perfect time to experiment, but that's up to you. Other than that, enjoy the jam. Good luck and have fun. Look forward to seeing what people create over the weekend. Thank you.